Welcome back to the next video, everybody. Today's video will be a quick one on finite Etale morphisms. So what are they? Well, a morphism of schemes y to s is finite Etale if it is finite flat in the sense we've already defined, and unramified, which means that for each little s and big S, the fiber y sub little s, which is just, as we've, I think, described before, y cross singleton s over big S. That's the spectrum of a separable algebra over the residue field kappa of s of s. So what I mean by that more precisely is y sub s is reduced as a scheme, okay? And for each little y in the pre-image over S, the fiber over S, the residue field extension kappa of y over kappa of S is a separable extension. Okay, so what's another perspective on all this? Another way of thinking of this concept is that all of the inequalities in the following string are actually equalities. So in general, we definitely have that the order of y sub s over singleton s is at least as big as the order of y sub s with the induced reduced structure on it over singleton s, of course, because y sub s is essentially a bigger scheme, so to speak. And then from basic scheme theory, this order here is just the sum over all the points little y in the fiber of the degree kappa of y over kappa of s, okay? And then, of course, that's bigger than or equal to, just by definition, the sum over all y in the fiber, big y sub s, of all the separable degrees of kappa of y over kappa of s. Okay, and so what you should really be thinking about here is you should be thinking about the typical geometric unramified maps from like complex analysis, complex geometry, what have you. You're looking for no pre-image points with higher multiplicity, essentially. I mean, there are some pathologies because this is scheme theory, but by and large, that intuition will get you far. All right, so we're looking locally for maps that are like, let's put this in quotes, n to 1, and the n points that map, that the n there should be like the degree of the map in quotes, and all the pre-image points should be distinct, right? Okay, so we can do a little bit better though, because the term point in scheme theory is very general and nebulous sometimes. A lot of different things qualify as points of a scheme. So let's actually just let alpha from spec omega to s be a geometric point of s centered at little s. That is, alpha is a map of schemes corresponding on the ring theoretic side of things using categorical equivalence to an embedding alpha tilde from kappa of s into omega, or kappa of s. And the point here is to be a geometric point, omega should be an algebraically closed field. I mean, what you're looking at, like a geometric point of a scheme is, it corresponds ring theoretically, or I guess it corresponds to a map spec, omega into the scheme S, and omega should be algebraically closed. That's all there is to it. Okay, and you should think of geometric points, if you've never seen this concept before, as just kind of the usual ordinary closed points on the scheme S. So what I mean is the actual points you might actually sit down and draw out if you're to draw the underlying topological space of the scheme. Now, this intuition only really works if S is defined over omega, but whatever. Okay, again, the intuition will still get you far in general. Now, the set y of alpha of geometric points of y that map to alpha under our given map of schemes from the last slide has cardinality. This is just a standard fact, again, from scheme theory, the sum of over y and s of the separable degrees of kappa of y over kappa of s. And so from the string of inequalities that we saw on a prior slide, we see that if y is finite flat as an S scheme, which is part of the definition of finite Etale, so we have to assume that, the inequality above actually will hold for a geometric point alpha of s centered at s. And then y will be Etale over s if and only if this inequality is an equality for all geometric points alpha and s. And so the upshot is, I don't really have to think of this as being an inequality for finite Etale morphisms for all points of my scheme, because I don't really want to think about all points of my scheme if I don't have to. I can just think of this string of inequalities as holding for the usual kind of typical geometric points of the scheme. And so that's nice. That makes things easier to think about. That jives more with our kind of undergraduate intuition about what points are. All right, and so next time we'll look briefly at the Etale fundamental group. And so I'll see you then, and thanks for watching.